Welcome back to our daily LeetCode challenge series. So today is day 32 and today we are going to solve LeetCode problem 66 plus 1. So we have given a large integer represents an integer array digits where each digits of I is the ith digit of the integer. Fine. The digits are ordered from most significant to least significant in left to right order. Okay, and the larger integer doesn't contain any leading zero. Fine. So increment the larger integer by 1 and return the resulting array of the digits. Fine. So basically we have to add 1 on the given digit. So we have digit array 1 2 3. If we add 1 here, so it becomes 1 2 4. So basically we need to consider this as a single number and we have to add 1 and top of that we have to return array itself. Okay, so in example 2 we have 4 3 2 1. If we add 1, so it will be 4 3 2 2. Fine, as expected. In example 3 we have 9, so if we add 1 it becomes 10, so we have to return output as 1 comma 0. Fine. So if we see our constraints, so we have the length max can go till 100 and digits anyway from 0 to 9 it can range, and digits doesn't contain any leading 0, so it is like starting will not be any 0, it should either be 1 or between 1 to 9. Fine. So what we can do here is we'll loop from back side, and if we see if the last digit is lesser than 9, then we'll simply increase and return. If not so, then we'll have to create one new array, right? And based on that we need to unlock. So let's suppose in example 2 it is single integer, so we can't modify here, so we have to return like 2 digit here, so we need to create the array in that case. Okay, so let's start. What we will take length of our current array dot length, sorry. So we'll simply run a loop starting from I equals to len minus 1, so we are returning back side, and I should be greater than or equal to 0 till first index and I minus minus. So here what we can do, we'll check if last digit, like from backside we're checking, right? If digits of I is lesser than 9, so we can simply increase by 1 and return y plus plus, and we'll return from digits from here itself. So in this case we need not create two new array. If our digit is not lesser than 9, then in that case we'll mark our ith value with 0, right? Because anyways if it is 10, then we have to mark 10, so ideally 1 becomes in the previous back side. Fine. If our second condition, in case we have only one digit or a starting digit is greater than 9, so what we can check here is if digit of 0 will become 0, so this is the last case. Then in this scenario what we have to do is like we will create one new int array, an array of int size or length plus 1. Okay, and we'll make a new array first index as 1. Fine. And then we'll simply return a new array here, and at last we'll return dates. Fine, let's submit and check. Okay, so our all 3 test cases got passed as expected. Let's submit and see other test cases. So yeah, it accepted all the scenarios. All 114 test cases got passed. Fine. So if we talk about time complexity here, so as we're iterating till n, so size of the given array, so it is big of n. So big of it will be in the roast case scenario, right? If last digit only we got it is the lesser than 9, then from here itself we are returning. But anyways, the roast time complexity here we can consider as big of n, and a space complexity in case and no 9 is present or no index 0 is present, then it will be of big of 1 because we are using the constant space, no extra space. But in case of if found 0 and need to create a new array, then it will be a big of n. So space complexity in the other case will be big of n. Yeah. So if you know like any other solution for this problem, you can comment it out. Till then, bye. Thank you.